Welcome to the Red Planet Project channel. If this is your first time here, this channel is dedicated to space exploration, terraforming, and the future of humanity beyond Earth. We discuss whether we can colonize other planets, how technology can help us, and what challenges our civilization faces. In our previous videos, we analyzed why we want to terraform Mars and what dangers await the first settlers. But today we will explore a topic that could completely change the way we reach space. Did you know that every space mission costs hundreds of millions of dollars? Sending people and cargo into orbit requires huge amounts of fuel, and the risk of failure is high. But what if, instead of launching rockets, we could simply ride an elevator into space? Sounds unreal. Well, this idea is being seriously considered by scientists. Today we will explore what a space elevator is, how it would work, and whether it will ever become a reality. A space elevator is a revolutionary concept that could completely transform space travel. Imagine a gigantic cable stretching from Earth's surface all the way into space. Along this cable, transport cabins could move, carrying people and cargo without the need for rockets. While this may sound like science fiction, the first concepts of a space elevator appeared as early as the 19th century. However, it wasn't until the 20th century, thanks to scientific literature, including the books of Arthur C. Clarke and NASA's research, that the idea started to be seriously analyzed by engineers. But how would it actually work? How could we build a structure that extends more than 36,000 kilometers into the sky? The basic idea of a space elevator is simple, but its construction is one of the greatest engineering challenges imaginable. Here are its key components. Anchor on Earth. It would need to be placed in a stable location, preferably on the equator. Some scientists suggest that the best solution would be an oceanic platform, which could easily adjust its position. Cable extending into space. This is the most difficult element to create. It would need to be incredibly lightweight while also being extremely strong to support its own weight and the transported cargo. Geostationary space station. Located at an altitude of about 36,000 kilometers, it would serve as the destination point for the elevator. This is where the journeys would end. Counterweight in space. Its role would be to keep the entire structure under tension and prevent it from collapsing. It could be a specially designed structure or even an asteroid brought into the correct orbit. If such a system were to exist, instead of launching rockets, we could simply ride into space, eliminating many of the current limitations. But is it really possible to build? What stands in the way? That's what we'll discuss next. If we manage to build a space elevator, it could completely change the way we reach orbit. Today, sending just 1 kilogram of cargo to the International Space Station costs around $10,000. With a space elevator, this cost could drop by a factor of 100. Moreover, today every rocket launch carries the risk of explosion, and statistics show that about 2 to 4% of space missions end in failure. A space elevator would eliminate this risk, making space travel safer than ever before. But what if the cable breaks? What then? There are different failure scenarios. If it breaks at ground level, the lower part would fall, but the upper part would remain in orbit. If it breaks at a higher altitude, a section of the structure could crash down to Earth with enormous force, causing a disaster. If it breaks at the top, fragments could shoot into space, posing a threat to satellites. This is why any space elevator design must include safety systems to prevent catastrophe. As of now, the space elevator is still a vision of the future. We lack the necessary technologies, but scientists are working hard to make it a reality. If these challenges can be overcome, we could be on the brink of a new era of space exploration. Do you think the space elevator will be built in the 21st century? Or is it too dangerous of an idea? Let us know in the comments.